So this is our last set of notes for this unit, and some of this may be a review, but let's go through it anyway, all right? What does melting mean? Melting means that we go from a solid to a liquid. And an example of that could be ice melts into liquid water. What is freezing? Freezing is the opposite of melting. All right, so this is when liquid becomes a solid. So liquid water becomes ice, and ice is a solid. So let's look on our third sheet that we've been looking at. Did you know? All right, melting point equals freezing point. So the temperature at which a substance melts is the same temperature at which it freezes. And we're going to dive into that a little bit more. Let's go ahead and define our phase changes. Now, all we're looking at here are our different types of phase changes, all right, which we defined in a previous lesson. Vaporization, this is when a liquid goes to a gas. And this is going to happen at the boiling point. So the temperature at which something boils. Now, vaporization is different from evaporation. All right, so we're going to talk about that difference in a minute. Vaporization, an example would be liquid water becomes steam. All right, now how is vaporization different from evaporation? Evaporation is a liquid that goes to a gas. But it happens below the boiling point. And an example of this would be evaporation. If we were to take a cup of water and place it on the desk and leave it and come back to it a week later, there would be no more water in that cup. What happened? The water evaporated. It went from a liquid to a gas. However, our desk in the classroom is at room temperature. All right, so the temperature that we are sitting in is not boiling. And this has to do, you'll talk a lot more about this if you take chemistry, but what happens is basically at the surface of the container, those liquid particles, because particles are always moving, those liquid particles are able to bounce with enough kinetic energy that they're able to go into the gas form right at the surface of that container. So that's kind of why evaporation happens, and you'll really dive into that more in chemistry. Condensation is the opposite of vaporization. This is where a gas goes to a liquid. Right? And an example of this would be gaseous water in the atmosphere becomes rain. All right, two terms that you may or may not have heard of before. Sublimation. Sublimation is when a solid goes directly to a gas without passing through the liquid phase. All right, and an example of this would be dry ice. If you've ever seen dry ice, this is how we do freeze drying as well. Okay, so when we are in a plant and we're freeze drying food, it works through the process of sublimation. Deposition is the opposite of sublimation. This is when a gas goes to a solid without passing through the liquid phase. And an example of this is how snow forms, okay? And this is why snow has a completely different texture than rain or sleet, all right? Sleet is actually water that has frozen into ice. So this is why they all have different textures, because we've gone from a liquid to a solid for sleet, but snow goes direct from a gas to a solid. So that's pretty cool, huh? All right, 2 more terms, and then we're going to make sense of all of these terms. The latent heat of fusion is the energy required to change from a solid to a liquid. And what this is some of the attractive forces are broken. And an example would be melting ice. Now, what do we mean by some of the attractive forces are broken? Let's come back up here and let's look at our picture of a solid. These particles are so close together. Why are they close together? Because there is an attractive force holding them close together. So when I go from a solid to a liquid, these forces that are holding the solid together are broken, and the liquid, our particles, are now able to move apart. Now, there is still some attraction between the particles in a liquid because they are close enough together that there's still an attraction. Gas particles are so far apart from one another, there's no more attraction at all. But solids and liquids, those particles are close enough together, they are being held there by an attractive force. And when you get to chemistry, you're going to talk about these, all right? So it's called intermolecular forces, and you're going to have a whole unit on these attractive forces. The latent heat of vaporization. This is the energy required to change from a liquid to a gas. And at this point, all attractive forces are broken. All right? All attractive forces are broken. So gases are so far apart, they are no longer attracted to each other. This is why if you are ever hit by steam, it can burn you. All right? Another example would be sweating. Okay? So let's take these vocabulary terms and let's look at them in terms of a heating curve. All right, so on our heating curve here, let's do water. We're going to make this water, okay? So we know that water freezes and melts at 0 degrees Celsius, and it undergoes a vaporization at 100 degrees Celsius. So my unit here is degrees Celsius. And my x-axis is actually going to be the heat energy. So how much heat energy is there? You may see it as time, okay? Physicists like to look at it as time. Chemists like to look at it as heat energy. So this is our solid. This is a liquid. And this line right here is our gas. Now, solids are very close particles, very close together. Liquids have particles that are kind of far apart, but not as far apart as a gas. All right? And so when we go from a solid to a liquid at 0 degrees Celsius, what are we doing? We are breaking those attractive forces in order to go and get these particles further apart. So what type of energy is directly related to the spacing of particles? That's potential energy. So at this point, when I go from a solid to a liquid, and we do call that melting, okay, so this is where we melt, we say these have potential energy because the spacing of the particles is increasing. Our particles in a solid we put kinetic energy down here. So the sloped lines are kinetic energy because the spacing of the particles is not changing in the solid or changing in the liquid, just the kinetic energy. Because what's increasing here? As I go up, what is on my y-axis? And that is temperature. And temperature is directly related to kinetic energy. So as my temperature increases, so does the kinetic energy. The potential energy changes at a phase change. So let's look at our final phase change. And here I'm going from a liquid to a gas. All right. So again, my potential energy is changing because my particles are spacing further apart. So we're changing the potential energy, and we call this vaporization. And I know this is vaporization because it is happening at the boiling point of 100 degrees Celsius. So heating a substance is going to change its what? It's going to change its energy. All right, and this makes sense because if we look back down here, as I heat a substance, what is happening to the amount of energy? I am also increasing my energy. So here's my initial energy. Then I heat my solid. Here's my final energy. So what happened? The energy did increase. So what I'd like for you to do now is I'd like for you to take this concept of a heating curve and apply it to a cooling curve. So a cooling curve is opposite, meaning we are cooling something down, all right? So going from a higher temperature to a lower temperature.